Hello and welcome to Skanska's Construction Market Trends webinar, hosted by Skanska USA Building. I'm Katie Wilson, Senior Director of Business Planning and Strategy, and I have the pleasure of being your moderator today. Thank you so much for joining us. We would love to know what part of the country or what markets and industries you work in, so please feel free to let us know in the chat. This webinar is meant to be accompanied by Skanska's quarterly market trends report that covers supply chain trends, material pricing, labor challenges, and other related construction industries. We'll drop the link to the report in the chat, and please be sure to check it out after today's webinar if you haven't done so already. Now I'd like to introduce our guest speakers for today. Nick.
Hello, I'm Nick Sherborough, and I'm part of our strategic supply chain team here at Skanska USA Building. Great to be here.
Hello, I'm Teague Murray, Vice President of Market Strategy with Skanska USA Building.
Good afternoon, Abu Bhargav, Senior Vice President Account Manager in the Boston office for Skanska.
Hello, I'm Russell Nix. I'm an Operations Manager with Performance Contracting Incorporated in Indianapolis.
I'm Dan Gentry. I'm an Applications Engineer at Train up in La Crosse, Wisconsin.
Awesome. Welcome, everybody. Today, we're focused on the booming life sciences market. But first, Nick will dive into the supply chain and materials update, and he'll also cover how changing tariff policies and geopolitical tensions are affecting construction pricing and lead times. Then Teague will give an overview of the life sciences sector, including what is driving growth and where expansion is overlapping with data center growth, creating busy markets. And then Abu, Russell, and Dan will join us for a panel about the life sciences market and how to properly plan for these projects. If at any point you have questions for our speakers, please add them to the chat. We've reviewed the questions you submitted beforehand and worked a lot of it into our content. However, we're hoping to save some time at the end for question and answers. We'll go about 15 minutes or so past the hour to allow for that. If we have any questions that we can't answer directly, we'll follow up with you directly. Finally, know that we'll be sending a recording of the webinar and the materials to all of you. Okay, with that, I'd like to ask Nick to dive into our supply chain and materials update. Nick?
Thanks, Katie. Let's begin by focusing on several key geopolitical developments: the Iran conflict, resulting energy shock, and shipping disruptions. All eyes are on the continued negotiations between the US and Iran. The current negotiations are working towards extending the current ceasefire to allow time for a larger peace deal. As these continue, pressure on the global oil market mounts. Pre-conflict, the price of a barrel of oil hovered between $60 and $70. In April, we peaked at nearly double that at $113 a barrel. As negotiations continue, we are currently sitting at around $92 a barrel today. There is hope that this will continue to drop if a deal is made and the Strait of Hormuz is reopened. We are certainly seeing this pressure at the pump, but beginning to see this as it relates to construction materials. Since the start of the conflict, we have now seen multiple rounds of price increase notices from major roofing manufacturers and other oil-based product manufacturers. We are also seeing fuel surcharges added to material shipping costs due to the dramatic price increase of diesel fuel. It is important to note that the Strait of Hormuz is not the only major shipping route under pressure. The Red Sea continues to see local shipping disruption, as well as the Panama Canal seeing major delays and bottlenecking as it relates to the increased natural gas shipments from the US to Asia. Now, shifting from global developments to regional framework, let's take a look at the USMCA agreement and its upcoming review in July. The USMCA agreement was established in 2020 with the intent to replace and modernize the existing NAFTA agreement. Now, 6 years later, the agreement is up for its initial review. This review is a pivotal moment for the North American trade framework. Mexico and Canada are two of our largest trade partners as it relates to the construction industry. Many of the products that they ship into the US are currently exempt from tariffs in place due to the USMCA agreement. The US, Mexico, and Canada are currently holding talks to review the terms of the agreement and decide whether to extend or modify. The next major step for this agreement occurs on July 1st, 2026. This is the date that all three nations must decide whether to extend or modify the agreement. This decision will set the stage for what the next 10 to 15 years of trade looks like for North America and could have significant ramifications for the construction industry. With USMCA as the foundation, let's turn to the reality of today's tariff environment. I'm going to focus on 5 main tariff types and what they look like today. First, the Section 232 tariffs, also known as the national security tariffs. These are applied to specific materials, namely being steel, aluminum, copper, and lumber. These tariffs have the largest impact on the construction industry, largely due to the materials that they affect. Effective April 6th, the 232 tariffs are now calculated on the full customs value of the imported product, not just the metal content, in turn, increasing costs based on the derivative makeup of the product. The restructuring was also broken down in the framework you see on the left-hand side of the slide. Earlier this week, the administration released a proclamation giving some additional detail to the new framework. Ultimately, this underlines the ever-evolving nature of these tariffs. Section 122 tariffs, also known as the temporary import surcharge tariffs, these tariffs apply to all goods not subject to the Section 232 tariffs. Although some recent legal challenges, these tariffs remain in place and are set to expire on July 24th of this year. The next set are the anti-dumping and countervailing duty tariffs. These 2 tariffs have been applied to Canadian lumber and are currently in effect at a combined rate of approximately 35%. The last set are Section 301 tariffs, or also known as the unfair trade practice tariffs. These are currently in place for Chinese goods. It is also important to note that the Trump administration is currently investigating the expansion of these 301 tariffs focused on 60 additional countries. This is a tariff type I would to keep an eye on in the coming months. Now, the last set of tariffs I will cover today are the IEEPA tariffs, or the tariffs enacted under the International Emergency Economic Powers Act. These tariffs were put in place in the spring of 2025 and were applied to specific countries at varying rates. Ultimately, these tariffs were revoked by the Supreme Court ruling back on February 20th. Now, on April 20th, U.S. Customs and Border Protection, or CBP, launched phase 1 of their system to process the IEEPA tariff refunds.
Wow, Nick, I just want to jump in here. So much going on with tariffs, as always feels like these days, but many customers are trying to coordinate with their general contractors to help capture tariff refunds. Can you walk us through what tariffs qualify for refunds and how the multi-layered supply chain makes it really complicated for those end users?
Yeah, Katie, that's a great question. As we begin to better understand the tariff refund process, there are 4 main items that I would like to focus on for owners and general contractors as they potentially embark on this process. The first one being verify the tariff eligibility. Assess whether the owner and general contractor are eligible for a tariff refund, and confirm that downstream subcontracts are structured in a manner that preserves and enables the recovery of such refunds. Additionally, only tariffs imposed under the International Emergency Economic Powers Act, or IEEPA, are eligible for refund. Other tariffs that were imposed and increased during the same period are not refundable. This includes, for example, the Section 232 tariffs on steel and aluminum products that I just mentioned. Those tariffs remain in effect and are not subject to a refund. The next major item is to identify and quantify the paid tariffs on your project. Understanding what tariffs have been paid is a key step. Projects that have a clear accounting of tariff types and value paid for each will allow for a simpler path to a tariff refund. This may be as simple as a change order paid specifically for an applied tariff. In some cases, a project could have been set up in a way that required bidders to break out specific applied tariffs, and in turn making the identification and quantification of those tariffs simpler. The third item is uncover path to the paid tariff. Having a clear path to the importer of record is critical to be able to identify, verify, and ultimately seek reimbursement. Many projects and sub-tier contracts are not set up in a way that support the downstream audit capabilities that this refund process may require. On the right-hand side of the slide, you will see an example of a construction material supply chain. You will notice the supply chain layers as the product makes its way to the project. It is important to note that this may be one of the simpler representations of that supply chain. often including additional layers of material handling. The light blue box represents the typical audit reach that owners and their general contractors have. The last item is identifying the importer of record. Now, why is this important? Because only the importer of record or licensed custom broker who filed the original entry can file a reimbursement declaration. Now, this is a very challenging process, and many things need to align all the way along the supply chain to create a clear claim to reimbursement. Most importantly, a clearly defined cost associated with the IEEPA tariff impacts, as well as a clearly defined legal right at each tier of the supply chain. Ultimately, every project and situation is different. In the spirit of properly setting expectations, in most cases, a clearly defined reimbursement claim will be difficult to assemble. Now, as we continue to make our way into 2026, I want to cover a couple key developments for material cost and availability in the construction industry. The first item, largely due to the pressure of the global oil market, we are seeing continued price uptick for oil-based products like roofing materials. I would expect to see continued price volatility in the coming months. Now, for some good news, we are also seeing lead times for major HVAC equipment and electrical gear begin to stabilize and in some cases retreat. This is largely due to the manufacturing capacity finally catching up to the demand of the growing data center market. On the right, I'd like to highlight structural steel and its continued uptick of both lead time and price. We covered this item during our winter webinar, and since then, we've continued to observe increases. This is largely due to the rapid growth of the data center market. For reference, lead times for structural steel were as low as 10 weeks back in the fall of 2025, just 10 months ago. And we are now seeing this top out at nearly 40 weeks. It is a good reminder that larger steel packages need to remain a focus for long lead procurement strategies. Now, as we move to the next slide, the first item I'd like to highlight is the price increase we are seeing on metal panels. These are largely made of aluminum, and in many cases are seeing the effects of the 232 tariffs that I mentioned earlier. The last item to highlight on this slide is the continued price increase we are seeing from metal stud manufacturers. Since the fall of 2025, we have seen a steady increase in hot rolled coil steel, resulting in a similar uptick for metal studs. We are now on our second, and in some cases our third price increase notice from major metal stud manufacturers on the year.
Wow, thanks so much, Nick. If you have additional questions for Nick, please add them to the chat and hang on for a Q&A session at the top of the hour. Nick, it's so helpful to see how material prices and lead times are trending. And while materials are driving prices across the board, the expected escalation across the country is bumpy. Busy geographies are experiencing higher inflation due to limited labor supply, but other geographies with slower traditional market sectors have more available labor and therefore subdued escalation. In our report's local forecast section here, you can see how escalation is expected to trend across the next 6 months to over a year. And additionally, you can find Skanska contacts to help you navigate local trends and properly plan project escalation. Now, Teague is going to join us to talk about where these geographies are seeing pressure from booming life sciences and data center markets and what is driving the life sciences market in general. So welcome back, Teague. There's been a lot of conversation around emerging sectors, but life sciences continues to evolve in its own way. From your perspective, can you tell us what you're seeing in the market right now and what trends are standing out the most?
Yeah, sure. So while emerging and adjacent sectors are capturing a lot of attention right now, life sciences is evolving just as rapidly, driven by its own set of unique demands, innovations, and investment dynamics. So let's dig into what's happening in this market and what's driving pharmaceutical growth. So we know it's not just one source, but a combination of factors, including innovations like cell and gene therapies and GLP-1 drugs, an aging population and chronic disease demand, renewed biopharma capital activity and strategic deal making, onshoring and supply chain resilience, and policy and regulatory environments. So while we know these aren't new topics, how do they translate into the construction industry? What ties it all together is the need to scale and manufacture these therapies, which is what's driving the surge in complex, large-scale construction projects. So while there is clearly a construction boom happening, only a small portion of this pharmaceutical activity, or roughly 10%, has actually been announced with defined locations in 2025 and 2026. Pharmaceutical companies have publicly pledged around $540 billion more in investments through 2030, but that capital still hasn't been tied to specific sites or projects, as you can see here on the map. But this is interesting because both new construction and renovations are common, but the mix is shifting between project type, lab versus manufacturing, and then also by US location. So now that we know the why, let's get to the where. You'll see here on the map the established markets, which we all know, but what I want to point out is the emerging markets and where significant expansion will be occurring for the next 5 years. The good news for all of us is it's translating directly into construction demand and spend over time, especially for large-scale manufacturing and highly specialized facilities like cell and gene therapy plants and API or active pharmaceutical ingredients and fill finish facilities. So we're seeing fewer speculative labs and more build-to-suit technically complex projects with a huge emphasis on speed to market and operational readiness. In some of the more densely urban environments like Boston, San Diego, etc., there's a much higher share of renovations and conversions versus new builds. But what I would point out are areas to watch, North Carolina, with really just the pure number of life sciences projects and clients, and then Houston, Texas, and Charlottesville, Virginia, with their several large campus projects that have been announced. In some cases, states like Virginia, for example, took a very proactive approach to attract pharmaceutical clients to the state.
Wow, Teague, it's just amazing the pledge of life science investment with so many locations yet to be determined and those identified geographies. I mean, just a lot of growth here in those emerging markets. How does this overlap with other markets?
Well, that's an interesting question. So what's happening with the large campus pharma projects and the overlay of where data centers are being built is called the collision point. The demand isn't just growing, it's stacking. So when both cluster in the same geographies, it creates one of the most intense and challenging conditions in construction. We at Skanska treat science and technology as an interconnected ecosystem rather than isolated sectors. So while each subsector has its own technical and regulatory requirements, they share common drivers too. So both sectors are extremely infrastructure intensive and rely on the same skilled labor, materials, and utilities. It puts pressure on local infrastructure, especially power and water, which can become a gating factor for project delivery. That drives up costs, extends schedules, and forces contractors and owners to be much, much more strategic around procurement and staffing. We do expect this to continue. As mentioned, the map is only showing 10% of announced and defined pharmaceuticals locations. But by treating these sectors as an interconnected ecosystem, as mentioned, it allows us to better anticipate constraints, manage risk, and deliver strategically in an increasingly resource-constrained environment. So that recognition naturally led us to ask, within this complexity, how do we bring greater structure, insight, and consistency to a fast-growing, highly complex, and rapidly evolving market? Instead of reacting project by project, how do we anticipate where the market is going and then guide our teams and customers accordingly? So we formed the Science and Technology Advisory Council as a central think tank of experts in our key market sectors to share lessons learned and best practices across the U.S. The benefit to our customers is that they get the best local construction team supported by the combined construction knowledge of Skanska's entire operation. Currently, you'll see here we have 37 S&T subject matter experts from our offices around the country. So speaking of SMEs, I am going to turn it over to my colleague Abu and others to dive deeper into some of these topics.
Wow, Teague, thank you so much for your insight into the market. Again, if you have any questions for Teague, please add them to the chat. And as Teague mentioned, let's now bring back our subject matter experts, Abu, Russell, and Dan, to discuss consider life sciences customers and how to move these facilities forward. So welcome back, everybody. Okay, so yeah, we know customers need clean spaces to perform much of the drug manufacturing processes. These spaces are technically very complex, they're costly, and construction can be approached in many different ways. One of the major considerations life sciences customers face earlier in the project planning is defining their clean space requirements and determining if they will benefit from a prefabricated approach to the clean space versus a stick-built on-site construction process. Can you share your thoughts on this? Abu, why don't we start with you and then maybe we can go to Russell.
Sure. The market is evolved over the years where a lot of the old facilities were built on stick-built with drywall and epoxy paint. And that has been migrated into prefabricated clean room pods and the prefabricated clean rooms. A lot of it has been driven by the cleanliness requirements and the cleaning agents that get used in these facilities again and again, and how much impact they have on the wearing surfaces. So that being said, which product is right? So I would say in the current market, we see more and more competition between pods versus the prefabricated clean rooms. And depending on the client, the need of the business, you can choose which way you want to go. We have been advising the clients on multiple locations on which is the right thing. One of the key things we notice, depending upon the project location and the vendor that you're going to be sourcing the clean room pods, the shipping costs could create a difference. In addition to that, even though the shipping cost could be there, but the cost of cheaper labor, material efficiencies, and doing the work in a prefabricated mode, you can pick up labor efficiencies. But still, we find that pods are typically more expensive than the prefabricated clean rooms. But as soon as you factor in the speed to the market, the pods can become very cost effective for an owner who's trying to build these facilities in an area where you may not have experienced labor force. If you go to the next slide. So one of the things that you see the picture, this is for a manufacturer where these pods are being manufactured across in a prefabricated environment. They are built with steel metal studs so they can handle any of the weights for shipping. Also, they are able to do a lot of the pre-work of mechanical installation, remote, including wiring devices and including fire alarm and control wiring. Some of the challenges that used to be, which was the flooring, creating spaces for additional height, the pod manufacturers have figured those things out, and they are able to do stacked units where you can have two pieces shipped separately and then assembled together on site. Go to the next slide. Then you have to be ready for the pods to be installed on site, and it has to be done with pre-planning. Like you see on the picture on the left, a lot of the mechanicals were already installed before we could bring the pods down. The warehouse had to be ready to be accepting the clean rooms. These pictures are for a project that Skanska did in Smithfield, Rhode Island. Considerations had to be made of how we're going to rig these into the building with the clear openings on the side. Shipping creates a constraint on what can be the sizes of pods that can be shipped. Just the sequence of delivery matters. Do you have enough space? And then if you go to the next slide, we have some pictures of completed pods that you see on the left side, and then you can assemble multiple pods together to form a full set of suites with the corridor and mal and pals completely built into it. The other thing is you can kind of do the similar things with prefabricated clean rooms built on site, and I'll let Russell go through that.
Yeah, thanks, Abu. Yeah, I think when you think about prefabricated clean rooms, just to give the audience some background, when we talk about a clean room panel and what it is, it's typically around a 2-inch thick aluminum honeycomb panel with a galvanized steel facing, and then that facing is lined with a UPVC liner. That UPVC liner is really important from a chemical resistivity standpoint. In the life science industry, these manufacturers need to be cleaning their spaces on a routine frequency in order to maintain the classification of their space. So it's really important that all the surfaces are resistant to the cleaning agents that they use. On top of that, they're typically purchased at about 4 foot wide for walls and about 5'10" for ceilings. The ceilings for most products are inherently walkable. That's a great benefit in that you can access your interstitial space without having to take down the room from below. And then also these panels, the way they come together, they always have factory finished edges at all joints. And that's important so that you have flush surfaces. You want a flush ceiling surface, you want a flush wall surface because you want to prevent opportunity for microbial growth, which can typically happen on ledges or horizontal surfaces. That's all avoided using this type of a system. So I think when you think about the system compared to stick built, some of the advantages there is that UPVC facing, it's going to generally appear better, look better, and be more durable over time. You don't have to like re-epoxy finish it on some frequency like you do with stick built. Additionally, it is a little bit faster to install, but there are some like watch outs. It does need to be coordinated a little bit more carefully. Shown here on the left are like, hangers that are required to hang the ceiling system. Because it is walkable, it needs to be hung from structure above or utilize some type of self-support system from the walls. And that does require some coordination with the interstitial space. It's very important that you coordinate panel locations, the rods for the panels with all the MEP, so you have a really functional interstitial space.
Wow, thank you both for taking us through those. A lot of great options to consider when building a clean room. How can our customers engage clean room partners as design build or design assist to benefit the project? And conversely, what are some pitfalls that customers should be aware of when engaging a clean room partner?
Yeah, here at Performance Contracting, we're typically onboarded in a design assist or design build relationship where we are brought on to work directly with the designer for the builder to help get the layout of the clean room panels and the ceilings and the walls done correctly relative to architectural intent. And it's really important to do that, around the base of the design phase because you want to prevent rework and reworking architectural layout. Like bring in the clean room panel provider, put the responsibility on them to lay these panels out to meet the architectural requirements. And because you can see on the left, if you do that well, you'll have a well-coordinated interstitial, which is really important for accessibility and functionality. You want on the owner's side to have a maintenance team that can navigate that space freely. And then on the right, when you look at the wall system, you think about the integration of the electrical outlets, windows, utility panels. When that's all done properly in the pre-construction phase and in the model, your construction is going to go a lot faster. In terms of pitfalls, I think what's important is to make sure that you have suppliers that are certified or proven to work in this type of design assist relationship, and also those that you can trust to stick to their cost basis. Obviously, you're pricing a furnish and install when design's not complete. So it's important to have a partner that can define their cost basis really clearly and quantify it in a way that's measurable and we, can be held accountable to. And also, a design partner that will speak very proactively regarding cost reduction opportunities or provide very quick signaling if there's design development that's leading to additional cost, so that the owner, the builder, and the designer have an opportunity to get ahead of that and make different decisions.
That's nicely put, Russell. A couple of things that I've seen is in a union town like Boston and some other markets, you have to coordinate of what gets installed by which trade on site, and that requires upfront coordination. Another key thing is if we are bringing the clean room vendor up early, we are essentially treating it as equipment where we work with the engineering firm, write the specification and create the layout and bid that out with unit prices written out and the expectation of that the clean room vendor is going to drive with a design to budget requirement with regular updates. And we have done that effectively on multiple projects. A UVA, Manning Institute being a recent one where PCI has been working very closely with us and working that through.
Awesome. Thank you both. So it's really about that early onboarding to make sure everything is coordinated and incorporated into the design for maintenance and performance. That makes a lot of sense. Shifting gears a little bit here, we heard from Teague earlier about the busy data center market and many collision points, as Teague put it, with life sciences across the country. We also know that the data center customers are buying MEP equipment months or sometimes even years in advance, and this directly impacts every other market. In the life sciences market, what materials or equipment are constrained by long lead times, and how are we working to overcome this to keep projects on schedule? Dan, why don't we start with you?
Yeah, thanks. From my perspective, I would say that the three things we hear are generally going to be chillers, generators, and switchgear. Because I'm with Train, we don't do switchgear or generators. We do chillers, however. So that's probably the biggest one. Now, what we've done as a company strategically is we've really separated data centers from everything else we do. So it's kind of its own business. And so we have developed and are continuing to develop data center specific chillers. So those would be, chillers that are designed to make elevated chilled water temperatures, think in the 65 to even 100-degree range for chilled water supply for these designs. And then they're also designed for air-cooled chillers to operate at way elevated condenser temperatures, like think 135, 145, something like that. Same with water-cooled chillers, the ability to operate at higher temperatures. So those designs are really specifically designed for those data center applications, whereas we're talking about life sciences, we're going to be, in the realm of chilled water, like we was for a typical application. And so what we have done is, since we have separate products for those, and we've actually, as the last couple of years, actually built new factories specifically for our data center chillers, or added lines into existing factories for data center chillers. So, we were talking about lead times at the beginning of this. So if you're looking at, data center chiller lead times, they are pretty far out there, but the conventional equipment that is going to be used for typical, say, comfort process applications like that is not as affected by that. And data centers used to buy more conventional chillers, but now that we've designed and evolved these chillers specifically for those needs, that's taken a lot of pressure off of the other industries that are buying equipment. I think I was to add this one more thing on that is, like, due to some of these, longer lead times, we have a lot of conversations early on about, coordinating, making decisions early on. There's stuff like modular construction that can also help with speeding up deployment. So there's some other things we can do just outside of lead time to help with a project.
I completely agree. And the other thing that has kind of grown quite a lot is on the architectural side. We have seen foundations, rebar cages, creating the box required for a warehouse or for a data center. Those with the roof trusses, the prefabricated metal panel with windows installed, you are able to construct the box so quickly. So the follow-up trades have to be ready pretty quickly after that. And then moving on from the architectural trades, in addition to the equipment, once you get in, having electrical rooms completely prefabbed, your restrooms completely prefabricated, and then moving on to getting pipe chases, both horizontal and vertical, buying equipment. Train and some of the equipment manufacturers have done completely prefabricated central unity plants. We have done air handling units completely done. We covered that few market trends ago. So that industry has evolved quite a lot, where with early decisions and planning, you can be fabricating those things as the building is going up. And then moving on to the pharmaceutical side, the equipment industry was very evolved on the pharmaceutical side already, with having equipment skids, super skids. A lot of the equipment was already pre-packaged to be delivered. We are seeing that more and more. And now the companies are relying on overseas vendors to supply those modules so they can be assembled very quickly in a fast manner, in addition to the projects getting the core and shell being constructed.
Awesome. Thank you so much. It's great to know that there's kind of that specific data center equipment that's less to affect the rest of the market. And then thanks, Abu, for taking us through some of those prefab options to make those decisions earlier. As far as equipment, many of our customers are trying to decarbonize with electrification, heat recovery, and other methods. And the US sometimes has different requirements for refrigerants and environmental protections compared to, overseas and Europe. What sustainability trends are driving the life science market, and what unique considerations do our customers need to consider as they incorporate these items into our projects?
Yeah, so I'm going to break that up into a couple answers, but the first one I'll take is the, let's say, electrification, decarbonization piece of that. So with the life sciences, we do see that like I'm going to say sustainability, just as a general term, as a big driver for a lot of these projects. And so electrification and decarbonization all ties into that. So I would say today we are well positioned for those. Say for those opportunities. We have a plethora of heat recovery and heat pump options available, from air source. We got water to water, capacity sizes as small as 30 tons all the way up to over 4,000 tons. So there's we have a huge range of solutions. I would say over the past 5 years or so, our heating portfolio has just gone gangbusters, if you will look at new product development and deployment. So the solutions are out there and available. Now, the point to the say unique considerations, I'm going to say, that's when we're talking about electrification and heat recovery and that stuff, it's really all about how that system comes together. So it's understanding what the system needs are. What does your load profile look like? What are the temperature needs and capacity needs? Those are obviously important. But what is the what does that equipment need to do? We need to talk about like, what does turn down look like? How does temperature control work? There are a lot of details to go through when you're looking at implementing heat recovery and heat pump systems into larger systems. Fortunately for say Trane has developed a lot of these guidelines, or say application guides and manuals to help our customers understand what things you have to look for and what things to be considering when you're going to be deploying this type of equipment. We also have people like myself and my greater team. This is what we do. We are here working with our engineering customers in the field to really ask all these questions and peel back the onion and figure out what is the ideal equipment system solution for this building type and its needs. So and I say we do that all day, every day with our customers, and we love helping out, because these systems, there is more things to think about, and they can be more complicated, and we want to make sure that we design efficient, reliable, easy to operate system, and can easily get out of that if you're not really paying attention to some of these details. Kind of, I would say, tied into the sustainability pieces, we do have EPDs, or environmental product declarations, for our different, I'm going to say for our larger chiller types, and we're starting to develop more of those. We're seeing that as a trend throughout different vertical markets, that people want to see these. So we do have some of those available. The last one then I would say is on the refrigerant side. So we're seeing we have seen for many years that a lot of these European-based companies want to really deploy those say systems, solutions, requirements in North America, and I'm going to say really hyper focused on the natural refrigerant part of that for my answer. I would say, early on with a lot of these, when we developed our 1233ZD, our low pressure centrifugal chiller, that refrigerant has a global warming potential of 1. And so that was a huge, gain for us and gain for the industry. And there was a lot of excitement, and life sciences dug that. We've done a lot of those projects, and that was exciting. But now they're starting to move the cheese, and they want to have natural refrigerants. And that presents an opportunity, or an opportunity, and also a kind of a situation. Our European products have a lot of natural refrigerant options with CO2 and with propane and some ammonia too. Now, we have used ammonia, and we do use ammonia in the United States, but that's I'm just gonna say it's a little controversial sometimes. And we don't really have as many like large scale, say, CO2 or propane products available today. So we're kind of stuck with what we have in North America today. Thankfully, though, the life sciences, specifically life sciences, is asking us to develop these and look into this and say, we need a propane heat pump. If you develop it, we'll buy it, we'll deploy it. So they're actually pushing us. Our customers are pushing us to start these developments in North America. So that's kind of something we're starting to look at, and hopefully in the future we'll have a nice solution for that.
One of the key things is a lot of the pharmaceutical clients have sustainability aspirations, and sometimes they are limited to what you can do for the manufacturing space. I know we do a lot for energy recovery, like we talked through it, but because they are limited to what they can do, they are trying to implement some unique solutions, bringing them to the lab and the office and the support spaces that go along with this manufacturing. I'm seeing more and more mass timber beams used to reduce the carbon footprint, focus on using low carbon concrete to be used. So any ways we can enhance the reduction of carbon footprint, that is playing into it to the sustainability side also. And in some cases, certain markets are driving that because of the regulations. Boston, California being some of them, where we have stretch codes that are mandated, which requires certain goals to be met for the project. Another thing is, just like you are seeing in data centers, you've got public pushback. So a lot of the owners want to do that as a goodwill so they can substantiate the sustainability as a means to get the project approved and make sure they are better accepted in the community they're working in.
Lots of different aspects for sustainability. Thank you so much for taking us through those. It'll be really interesting to track natural refrigerants in the future. So thank you. I want to go back to the labor availability to build these facilities. I know Teague mentioned earlier, but there's geographies where life sciences and data centers are booming, like North Carolina, Houston, Charlottesville, Virginia, and parts of the Midwest. How are our teams overcoming labor shortages for the specialty trades required to construct clean rooms and mechanical plants? Dan, why don't we start with you, and then maybe Russell can add in.
Yeah, I would say, we're all aware of the shortage in labor for trades and manufacturing in some places. And obviously, Train, we're very aware of that. And so what we've done is trying to be proactive, obviously. And so we have all kinds of different training programs. We have training programs here in La Crosse. We have programs over in Davidson and at other sites as well. So we have programs for training our new employees. So we can really, I'm going to say, take somebody off the street, put them through our training program. They learn how to weld, they learn how to assemble, like in our factories. And we've had a lot of success with that program. And over the last few years, it's just exploded in size. I know they had a couple stations over there now. Now they got a whole wing of the training center, which is great to see. And we've also done a big one is technicians, chiller technicians, experienced good chiller technicians is a huge thing right now. We just opened up a new center in North Carolina, where we're going to be ideally getting thousands of techs through that every year. So, like I said, that's open and kickoff. I think we just had the first class come out recently. So, really trying to do our part to get people in, get people aware of the trades. I know we try to just do that as a company, as an industry, to reach out to schools and kids and young people and get them excited. I host a podcast, and we talk about this on the podcast as well. That's saying, we had somebody come in for it was called a heavy metal summer experience. So it's a summer camp that they develop and get kids excited in the trade. So like that kind of stuff that I think our industry, we should all be trying to get folks to go in the trades, because it's a good job. It's a good paying job. It's going to be around for, I would say, for a long time. The other thing with, I guess, training too is maybe it's kind of training. I'll call it like educational. Is like my team, we do a lot of training with the field. So doing like educational topics, like how do you set up a variable primary flow system versus a decoupled system, and how do we implement heat recovery chillers? What are the things to think about? So we do a lot of training with trying to get, say, our engineering customers up to speed with new stuff, what's going on, how to apply this stuff. So I would say we're trying to train across the board almost everywhere. And I know we've maybe heard it before. It's a saying we've heard as train trains the industry, and I think that is actually a true thing to some extent.
Yeah, I think I think for us, what we're seeing in a lot of these different locations, we're seeing a lot of builders and owners be more proactive in their relationship development in terms of how they identify key suppliers. Once again, proactively to make sure they have enough individuals ready to go and service these locations. It's helpful for us, like at PCI, it helps us identify how we mobilize our different offices in order to service these specific locations feasibly. I'd say when it comes time to the proposal, what I'm also seeing is we're seeing requests for much more detailed proposals where you definitely have to demonstrate your capability of serving the job reliably and somewhat proving that, maybe more so than in the past. So while commercial terms are still important, I do think builders are taking a more critical lens at suppliers' capabilities to do these jobs effectively. Hey, depending on local market conditions, I've seen a couple other specific situations where incentives are happening for specific crafts. If those crafts are, being able to demonstrate that they can't bring enough people to the job site. But once again, that's very job site specific, very craft specific. Finally, another thing I see a lot of is requests to leverage offsite prefabrication, to leverage offsite prefabrication to help offset on-site labor needs. I've personally seen some mixed results. I've seen some good success stories. I've also seen some instances where the offsite prefabrication costs more than people are willing to pay, or while the offsite prefabrication could work, it needs to be done earlier in upfront design coordination to realize the benefits of that prefabrication approach. And sometimes those windows can get missed if prefabrication is talked about too late in the project delivery model.
Yeah, thank you so much. I mean, I love the, prefabrication options go back to kind of our conversation earlier, and just making sure you're capitalizing on that earlier in the project planning phase. And I also love that we're doing all the training. And Dan, I love the name of your summer program of the, what was it?
Heavy metal summer experience.
Summer.
Yeah.
I think that might warrant like a custom song with that actually, but Abu, from a contractor's perspective, what approaches are you seeing to work to help deliver these mega projects in busy areas?
So just like working in the field, we are seeing that in the engineering or the CM construction trade, it is becoming overly difficult for the construction managers, EPCM firms to man up for these mega places and then suddenly ramp down when these are getting done. So a lot of there are partnerships getting formed to execute these projects together. We're seeing that more and more. Another thing that is happening is some of the overseas companies where some of these fabrication facilities were getting built are not getting built anymore. So they are slowly trying to come into the US market, and they are partnering with the existing companies so they can deliver these things overall. So I would say, yes, it is making us all get along, is what I would say.
I love that. It's great to hear about how, we're kind of working together to really get creative and get these facilities built. Let's talk about life sciences trends. Teague mentioned massive growth in the GLP-1s. How is that affecting the market? Russell?
Yeah, I think just to start with what a GLP-1 is, so it's a natural hormone made in the gut after you eat that helps you like regulate blood sugar and appetite. And what they've seen is success in the marketplace for treatment of type 2 diabetes or management of type 2 diabetes might be a better way to say it. And also, some approved products for a weight loss indication. So I guess what we've seen, and to note, Teague mentioned 10% of the investments have been announced in terms of location. So there's a lot more coming. But in terms of, what we've seen today, these GLP products that are on the market are peptides, which peptides are short chains of amino acids. And the peptide would be the active pharmaceutical ingredient used in these injectable products. And generally speaking, manufacturers don't have enough peptide manufacturing capacity in their existing portfolio relative to market demand. So in the last couple of years, we've seen a lot of significant investment in peptide-related facilities for GLP-1 products. With that said, when you think about the downstream aspect of making the APIs filling into injectable, there still are some injectable manufacturing facilities being proposed, but there's a little bit less. There was a lot of investment into those type of facilities during COVID. So there's, I guess generally speaking, more manufacturing capacity on the fill finish side than on the upstream API side for GLP-1s. But even beyond peptides, there are some new GLP-1 products that are in clinical trials that are actually small molecules. Small molecules would be small chemically synthesized products that are actually generally stable in the stomach and then can be taken orally. So you're hearing about oral GLP-1s. While those products are coming, we're also seeing some large investments in new small molecule API facilities as well.
Thanks, Russell. You mentioned, API, active pharmaceutical ingredients. What's the difference between that in comparison to the facilities that have been built in the past? And are there different requirements of the, the building team?
Yeah, generally speaking, API facilities are larger. If you think about an injectable facility, a fill finish facility, it's really all about that filling line. The product's, already been made per se, needs to be formulated and filled. Filling is the most critical quality step. So I think we're all aware of how critical it is to get the appropriate filling machine designed, delivered, and then a clean environment built around it, clean utilities, et cetera. As you move upstream from that, you talk about active pharmaceutical ingredient manufacturing. These plants typically tend to have larger process vessels. There might be multiple chemical synthesis steps required to get from your starting reagents to your downstream finished product. And in that, they typically are going to leverage larger process vessels, more fixed piping. At times, you may see the utilization of hazardous solvents that are going to require specific safety design standards and special hazardous waste handling requirements. So in essence, in my opinion, API facilities can more closely mirror large specialty chemical plants. The differentiation is that you have to integrate these clean environments around them, which can be a little bit complicated when you think about the size of these vessels and therefore the size of their rooms. And even though like upstream API manufacturing is inherently less product quality risk than downstream injectables filling, I think there's a recognition that these spaces still have product quality impact, and it's important to build them in a way that have good facility appearance and ultimately impress regulators who have to tour these facilities and approve these facilities for release to make product for their regulatory market.
Okay, thanks, Russell. Very specialized expertise is needed to deliver these facilities. So thanks for taking us through that. It's really interesting to hear about how the trends and the drug advancement are really driving the market, between injectables and oral drugs. That's very interesting. Abu, what about cell gene therapy? What are we seeing in this space?
So as the industry evolved, where we did work for Dana-Farber, the work was getting done in a personalized medicine, and the rooms had to be cleaned up very often. As the industry has continued to evolve, the equipment has gotten better, the data crunching has gotten better, and moving to the Gen 2 and the Gen 3 generation, the clean rooms are evolving to volume type clean rooms, similar to what happened on the semiconductor side. And the materials management or movement is also continuing that perspective overall. So I think we are seeing on the cell gene therapy that as the new projects are coming up, they're geared towards having a bigger room set up, and then the equipment can be brought in as the project evolves even more.
Okay, great. Thank you, Abu. Well, thanks so much, Abu, Russell, and Dan. I'd now like to ask Nick and Teague to join us once again, and we'll take a few questions till we run out of time. I think quite a few of our colleagues have answered questions in the chat, and we also had some other colleagues on the strategic supply chain answering questions as well to kind of help there. But let's see, I think we have one question that wasn't answered yet. Is there a big use of high temp filters within these pharma facilities? I'm not sure who could maybe tackle that one.
Yeah, I guess I could speak to maybe two items. I think from an air quality standpoint, different rooms have different classification requirements. You think about ISO 8, ISO 7, et cetera. There's definitely a need to drive clean air into these spaces. So the air handler duct systems have to be sized for specific air changeover rates based off of room classification. And there needs to be clean air that comes to the rooms. Most typically in life science, what we see is a terminal HEPA unit in the ceiling, in the clean room ceiling, that the air is pushed through. That way the air is filtered directly at the point of entry to the room. And then from a return air standpoint, we typically see like low wall returns, that air as it comes into the ceiling is driven down in a laminar flow perspective to push any particulates down to the floor level and then pulled into the return system. Obviously from a bulk processing standpoint, the use of in-process filters for solutions moving upstream to downstream is a significant part of the contamination control strategy for any life science manufacturer. And that filtration strategy, both, proving, filter integrity, utilization of filter, documenting all those in-process filters and utilization is really important from demonstrating a product quality control perspective.
Awesome. Thanks so much, Russell. I think we just got a new question, and maybe Teague, you can start off with the answer to this, but do you expect the 90% that's not located in the life science market or hasn't been identified to be located in 2026, or do you think it'll take more time?
I think, just from the research that we've done as a team, I do think 2026 will be a strong year for pharma announcements and site selections for sure. But I think as far as how many will actually break ground and be constructed, I think this will probably unfold over 3 to 5 more years.
Okay, well, that's good to know. I'm glad to hear that it's 2026 is gonna be a good year, so, or located into the next year. So, Dan, I think you answered this question in the chat a little bit about how we cross-train employees for succession planning, as well as training new employees. And I know earlier before we got a question from one of our registrants about how do you see transferable skills stretched across other industries like residential to life science projects? Is there anything you want to expand upon, or I know you answered in the chat, so.
Yeah, I mean, I would say like I'm going to say the beauty, one of the beauties of say HVAC equipment is you're just trained on the equipment and the system, and those systems may vary like a little bit from say industry to industry. But if you're a chiller tech, you can do chillers, and it doesn't matter what kind of industry or not that they're in. Now there may be some, within different industries, different nuances with how they operate the equipment, or maybe what their controls interface or interaction looks like, and those will be unique. But those are all things that are, I'd say, if you're generally speaking about chiller techs, that they're aware of, comfortable with. So I think, yeah, the nice thing is these technicians can be really used and at any industry. We don't really have a market type for technicians. Now we're probably going to have some data center technicians because that's where that's driving, and we want to be able to take some of that labor pressure off of say not data center customers. So I would say the good thing is that their skills are transferable.
Yeah. That makes a lot of sense. Abu or Russell, anything you want to add as far as getting the right people into these markets?
I would say one of the biggest trades that it's getting impacted are the electricians, because data centers need them more than anybody else. And then also looking at what do we need for the controls that are there. So I've seen a push for the unions in the Boston market, that they are pushing to attract more kids into it. Vocational schools, I'm seeing effort in there. We as an industry in Boston, we have ACE, where we are going and presenting to the high school kids, like Dan said, asking them to join the trades. I think there's a lot more emphasis on that. There are sort of subcontractors, just like Train. They are running training programs for the kids, so that way they can then take that as a career overall. And you're right, with the overtime money that is out there and everything, you do get to make a good, decent living working with your hands from that perspective.
Yeah, certainly union engagement across multiple different crafts specific to your market's really important. Yep. For us, we're signatory to the Carpenters Union. Carpenters Union has been excellent. So we're very lucky to have that relationship, but we work very hard to foster it. Hey, as you enter different markets, it's important to kind of assess the strength of the union in that specific market, and where they're strong, leverage them. Like, they're going to service you. If they're not strong, then you have to start thinking about out of town and how you bring in partners from other markets to service that. And once again, just get back to being proactive. and doing that relationship development up front so you know you've got a good labor plan to service the job site.
Great, thank you so much. One question we have is, as life science facilities are pushing towards higher cleanliness standards and faster project schedules, where does the industry actually stand on plastic versus steel piping? And are there traditional assumptions about long-term durability and system compatibility, still holding up? Or are we seeing these shifts on larger complex projects?
I can take that on. I would say I've not seen a lot of plastic piping on the systems where we were traditionally using stainless steel piping. I would still say the cleanliness requirement that is required for the piping and the extent of cleaning cadence required for these do not allow for them to go to plastic pipes, only for certain chemicals or PVDF we have used for certain systems. So that is there, but I don't see that certain systems would transition into plastic piping. I don't see that happening anytime soon.
Okay, thank you. We did have a question about what's the typical time from ground break to hand over to the end user. I'm guessing it might depend on what type of facility, but does anybody want to kind of give an overview of that time frame?
I can take that on. So it depends on the bigger campus projects. The turnover doesn't happen overnight. It is spread over a year or 2 years time frame, where you can start turning on the central utility plant, the lab offices. Some of those things will get turned over soon, and then they're followed with the manufacturing. So the startup can continue to happen. And even after, so I'll call it anywhere from 2 to 3 years, you get to that point. But even after that, you don't stop there. The client would typically have a year to year and a half to get the validation, commissioning, everything complete, trial runs done before they can really get the approval from the FDA done, before they can really call the facility clear to be making product that can be sent over to consumers. So the timeline can be added in that terms, could be 4 to 5 years in that case.
Okay, great. Thanks for giving that kind of general overview. I appreciate that. I know we talked a lot about prefabricated pods and options today, but there was a question about, are there any field labor issues with the prefabricated pods? I don't know if Russell, you want to start with that, or maybe Abu?
Yeah, Abu, why don't you provide your perspective?
So for the pods, because most of the mechanical systems were ready, the only field labor is to assemble the pods. Typically that was being provided by the pod manufacturer with some assistance from the local trades or hiring from the union. And then rest of the tie-ins for the mechanical trades were done by the normal contractors who are very experienced in working on the clean room. So I would say in case of pods, the minimal requirement that you have to do is not a problem. And then Russell, I'll let you speak to the clean rooms because you did that more than that side.
Yeah, I think when it comes to the prefabricated clean room panel system, and I'd say there's certainly not a labor shortage as much as it's just important to get experienced installers that understand the system. To go and acquire some, union carpenters is probably pretty straightforward, but people that actually know how to utilize this clean room panel system and build it flush and build it, I'd say in a hygienic manner. What you really need at the end of your project is a fully architecturally sealed envelope. So you need installers that know how to do that. And that's why, from our perspective, it's important that you ensure that you are selecting a supplier that has experience with the systems and has demonstrated their ability to mobilize experienced labor to complete that work on site.
Awesome, thank you. Just sticking to the construction processes, we have a question about how important is it to monitor particulates during the construction phase and flush out at commissioning for the life sciences projects? I think maybe this is a good one for you, Abu.
Yes, it is very important. As you saw some of the pictures we showed for both prefabricated pods and even in the clean rooms, the space was very, very clean. And even before you get to it, there are very distinct requirements to flush out the space so that way we don't have any particulates from there. And after that, we do work with the clients and have a very clean build protocols in place, which is escalated as the construction continues to happen. We start to use floor mats. We start to use filters. We are circulating air through very often. And as the project progresses, and by the time you get to the clean rooms getting constructed, we have to make sure the air is circulating. The other big piece, as Russell said, is the surfaces are all to be cleanable and flush. So just as an example, all the caulking that is required, you need specialized trade people who are conversant with doing that work. You cannot take a normal painter and expect them to go do caulking in the clean room from perspective. And all of the time we are doing this, our air is already circulating with it. We have to be very careful about not contaminating the returns. We have to have filter fabric on the returns during the time frame. So we do all these things. We even have temporary filter fabric at the air handling unit, so that way as we're supplying it, don't install the HEPAs very early. There is very close care has to be done to install the HEPAs. We try and buy that as a composite crew, not only with the HVAC and the clean room vendor, but also having the client's metrology, so that way those can be qualified as the HEPAs gets installed, and that way the trending and everything is set from that perspective. So yes, it is very important, and there are a lot of considerations that go into that to make sure that we control the contaminants, measure that too, and then make sure the building is turned over the right way.
Awesome. Thank you. There was a question around what is the time frame we're giving for the 4 emerging markets, Dallas, Salt Lake, Minneapolis, and Virginia? When do you think we'll start seeing more projects in these markets? I don't know, Teague, if you want to start, and then maybe we can see if anybody else has any opinions here.
Yeah, I would say we would start seeing momentum over the next 1 to 2 years, but I think the real construction would probably ramp up more meaningfully over the next 3 to 5 years.
Okay, great to know. One thing I did want to point out is I think, Nick, your colleague Tom wrote back to an answer in the chat about long lead times for current chillers, generators, and switchgear. So I just wanted to mention that in case anybody had a similar question and wants to look at that response. The last question I think that we've gotten so far is PFAS, and is it PFAS a concern in life sciences? Does that ring a bell with anybody?
I can just comment very briefly that it has come up, PFAS has come up with refrigerants, with the 1233ZD. I'm not an expert on that. We do have some write-ups and conversational pieces about the refrigerant and what that looks like. But that, I would say, with life sciences, that from our side, on the refrigerant side, that question does come up more often than not, I'm going to say. And we have some stuff to talk to that. But outside of chillers, I'm not sure.
It doesn't come up very often on the life sciences side.
Yeah, that's what I was
more
just
on
about to
industrial side, not as much on the life sciences.
Okay. Well, thanks everybody for that one. Okay, I think we have maybe one last question we'll take, and it's what are the biggest disconnect between the owner expectations and the field reality on these projects?
I would say the biggest one is these can be built in less than a week. And we think it's more than 2 years. So no, the desire to get to the market for certain things is the key thing. And then they are pushing us as an industry. I'm talking about the engineering firms, the CM firms, and the vendors and the manufacturers from that perspective. How can we get to these things quickly and get to them in a manner that we don't trip over ourselves and make mistakes and do it very efficiently? So I would say that's the biggest thing for the expectations for the clients. And I would say we all strive to get to that part of it for sure.
Awesome. All right, thank you. I think we're running up on time today, so I want to thank all our panelists and everyone that joined us for Skanska's Market Trends webinar. And please be sure to check out the full report. Thank you so much.